Okay, so continuing on our chapter about circles. This section is about the angle measures and segment lengths of different lines cutting through a circle. Okay, so we're going to be looking at if it intersects inside a circle and also if it intersects outside of a circle. Okay, so let's start off with this. So, quick review with this. So we've got A, B, and C. Okay, so take a second to remember the blue line there is a tangent line, B is a inscribed angle, and A is a central angle. So take a second, find A, B, and C. Okay, so A is the fairly easy one to find. A is the exact same measure as the arc on the outside, so A would be 140. B would end up being half that measure. Half that measure, which would be about a 95, no, not 95, 70, would be about 70, so it'd be half of it. And then the leftover, or C, would end up being half of whatever the leftover angle is. So you would take 140 plus 125, subtract it from 360, and you would get that arc as 95. Okay, so that arc would be 95, and then that angle would be half that measure. So it ends up being about 47.5 degrees. Okay, so that's one way of doing it. Another way of doing for C is to find the measure, find this measure, and then find this measure, and then subtract out 180. So there's a few different ways of doing it. Okay, so the measure of the angle formed by two lines that intersect inside of a circle is always half the sum of the measures of the intercepted arc. So this is assuming that if you have two in a circle, you intersect two lines, but they don't cross at the center. Okay, well, they can cross at the center, but we're looking at it as if they don't cross at the center, how do you find that measure? So what you would do is you end up taking, when you have your two lines intersect, and let's say we want to find angle 1 right here, what we would do is we'd take this arc and this arc. We'd find the average of them, essentially. Okay, so we'd find the average of those two to be able to find what the measure of the angle is. Okay, so it's 1/2 x plus y. So you find the sum of the arcs, intercepted arcs, then divide them by 2. So find the average. Okay, so here's one way we could do it the other way. So we have the intercepted arc and we have to find it. So this would end up going here, and then the 100 would go in for y, and we have to find x. Okay, so take a second, find the measure of x. Okay, solve for x in this equation. See what you get. All right, so with this one, as we plug everything in, we end up getting 70 is equal to 1/2 times 100 plus x. Okay, so we end up with that. And then first thing we would do is multiply both sides by 2, getting us 140, and then subtracting 100, which means x is probably 40. Okay, so that means that arc is a 40-degree arc. Okay, yes, it's not to scale. That's what we would do. We'd plug in our numbers and we'd solve. Okay, so the next one is if we have our two lines intersect outside of the circle. So if the two lines intersect outside and we want to find that angle, instead of adding the two angles together, we're going to subtract them. So you take the larger minus the smaller and then cut them in half. Okay, so this is if they intersect outside of the circle and not inside. So you take the difference of the two and then you cut it in half. So the outside angle should be smaller than both the intercepted arcs. Okay, it's always true. That outside angle should be smaller than the intercepted arcs. Okay, so take a second, find this one. Again, 25 would end up being your number, so you'd end up with 25 equals 1/2 x minus 45. Okay. So now when we solve this and we set it up, we'd have x minus 45. First thing we would do is we'd multiply both sides by 2 to get rid of that 1/2, getting us 25 turns into 50. So that gets us 50 equals x minus 45. So then we would add 45 to both sides, getting us 95. So we'd end up with 95 minus 45 divided in half gets us 25. Okay, so next one's dealing with the lengths of the intercepted chords. So if you have two chords that intersect each other, what end up happening is that the segments of them are proportional. So if you multiply the lengths of the segments that are being intersected, okay, if you multiply each segment to each other, you end up getting the same number. They end up being proportional, okay? So it ends up being, you could rewrite this also as A over C is equal to D over B. That would be one way of doing it. There's a few other ways that you could do it as well. So you see you kind of multiply these together, or you divide the, you divide these, and it should be the same as if you divide those. Okay. So the easier way of doing it is just multiplying, because multiplication you don't have to worry about these decimals or anything. So take a second and find your x. Right. So when you're doing your multiplication, hopefully you went 3 times 7 is equal to 6.5x. So then it would be 21 divided by 6.5, which gets you about 3.2. Okay. So 3.2, 3.23, anywhere along there. So you get kind of a not a whole number, not a nice fraction. Okay. So again, multiply one length, one chord's lengths, and that equals the multiplication of the other one, or the product of the other one. Okay, so now dealing with the segments if they're outside of the circle. So if they cross outside the circle, how do we find them? And what you would do is you take the entire length of one side and you multiply it by the outside. Okay, you take the entire length and you multiply it by the outside length, and they should be equal for both lines. So when you have your lines going through the circle, if you take the length from the edge of the circle to the point of intersection multiplied by the first intersection point to the intersection, they should always equal the same if they're crossing at the same point of intersect. Okay. Okay, so let's say we have this one, which is on the outside of it. Okay, so this is x, which if we want to find x, what ends up being is that we actually are trying to find w, okay, because it's on the outside of it. The variables don't match up. So with this one, you'd have to set it up and you'd go w, or 4 plus x times x is equal to, I would go 5 plus 2, 7 times 2, 14. Okay. So I'd end up with that. Multiply it in, getting me x squared plus 4x equals 14. And now what I'd have to do is I'd have to use either the quadratic formula, completion of the square. I'd have to do something to find my x values. And I'd want to make sure that they are positive, because if my x values are negative, those aren't the right answer. Okay. So from here, we'd have to use the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a, to probably solve it. So we'd end up with x squared plus 4x minus 14. Okay. And so then we'd use our quadratic formula. When we do our quadratic formula, we end up with an answer of 2.2426, yada, 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 yada. It's actually a radical that we end up getting. Okay, so you can take a second, you can use the quadratic formula, solve for your x, and see if you get the same answer that I have gotten. All right, so if we're looking at this one, Okay, so we've got our new one, and we've got a tangent intersecting with a line segment outside of the circle. And this is very similar to our previous equation because what ends up happening is the sum of the entire length, okay, multiplied by the outside. Well, the entire length of this tangent is just the length of the tangent multiplied by the length of the outside, which is what? It's still the tangent. Okay. You can also think of it if we wrote it with the sum of the inside part, because it's the sum of the in and out multiplied by the outside. The sum of the inside part would be 0 because the tangent doesn't go inside. Okay. All right, so take a second, find t in this example for this. Okay, so if you did 9 times 4, so the sum of the length would be 9, times 4 gets you 36, square root of 36 gets you 6. So our answer would be our positive 6. Alright, so those are a whole bunch of different formulas to find the lengths of chords inside of a circle and also the angles inside of a circle. Okay, so here's your homework in this section.